Hi everyone, I'm Akshatha Gopinath, a first-year PhD student at the University of Amsterdam. I want to talk about observing fast radio bursts with LOFAR at very low radio frequencies. Now, as we know, a signal from a fast radio burst undergoes various propagation effects such as dispersion, scattering, and Faraday rotation. Scattering and Faraday rotation are especially more pronounced at lower frequencies than they are at higher frequencies. This can be a double-edged sword, meaning it makes detectability harder at lower frequencies, but also that it provides us much more precise constraints on these measurements, allowing us to get key clues about the local environment of the source. Now, earlier this year, Clunas et al. Reported the lowest frequency FRB detection of FRB 2018-0916B or R3, which is a repeating FRB with a period of 16.3 days. Bursts were detected down to 110 megahertz. What we also saw was that the bursts at LOFAR frequencies occurred around 2 days later than the expected activity window from the CHIME FRB observations. What we wanted to now do was to ascertain that this delay in activity phase was real and put good constraints on the LOFAR activity window, as well as see if we can observe more sources at LOFAR frequencies. So we followed up around 6 CHIME repeaters with LOFAR marked here in blue circles. The Clunas et al. Bursts that are marked here below this horizontal line were done with observations scheduled just around the CHIME activity window. In order to constrain the window better, the LOFAR window better, we sampled the whole activity phase uniformly with observations scheduled almost every other day in the last 6 months. This gave us 2 new bursts with the same amount of observing time as Clunas et al. This meant that the burst rate had fallen by around a factor of 10. This could be due to various factors, one of which could be an increase in the scattering timescale. The scattering timescale measured for the Clunas et al. Bursts was 50 milliseconds, while it had doubled to around 100 milliseconds for the 2 new bursts observed. We also continued monitoring any RM variations of the source. To remind you again, LOFAR provides unparalleled 0.1 radians per meter square precision in RM measurements. Here you can see the rotation measure versus time, as well as activity phase. We also detected a second repeating FRB with LOFAR, FRB 2019-0212B or R14. We only detected 1 burst from this source, which was very weak and also very narrow banded. It occupied around 15 megahertz out of the 90 megahertz observing bandwidth. Hopefully, this is a sign for more bursts to come from this source and also for more sources with LOFAR. The key takeaways from this were that continued LOFAR monitoring of R3 pointed to a decrease in the burst rate, possibly due to a doubling in the scattering measure. Both scattering measure and RM constraints can provide important clues about the local environment. We also detected a second repeating FRB R14, which is a promising source for continued LOFAR monitoring.